authors proposed to switch YOLO detector to anchor-free manner. Then, as a next contribution, authors suggest advanced detection techniques like decoupled head and the leading label assignment strategy, which is called SIM-OTA, will be discussed later. It enables authors to achieve state-of-the-art results. Also, in addition, this paper got first place on autonomous driving workshop at CVPAR 2021. And at that time, YOLO V5 was the latest version and the one with the highest performance. But still, YOLO V4 and the YOLO V5 were anchor-based detectors. So let's get into the YOLO-X architecture. The first one, authors use YOLO V3 with darknet 53 as baseline. And the first contribution that they made is they use decoupled head. So as you can see on the picture, here it is YOLO V3 to YOLO V5, where they use the shared head to predict mainly three values, which are classification score for regression bounding box coordinate, object score. While in YOLO-X, they propose decoupled head. So first of all, they adopt a one-to-one convolutional layer to reduce the feature channel to 256. And then they add two parallel branches. One is serving for predicting of classification scores, and the second one is used to predict regression task, and also IOU branch is added on the regression branch. And as you can see here on the table, by adding decoupled head, it allowed to increase AP score for 1.1 compared with YOLO V3 baseline. Second contribution that the authors made is that they use strong data augmentation. They use two types of augmentation, which are mosaic and mix-up augmentations. So here is the example of mosaic augmentation, where basically they combine 4 images in one and try to detect not only one object in one image, but 4 objects in one image. And mix-up augmentation is data augmentation which generates a weighted combination of random image pairs from the training data by using some parameter lambda, as you can see here. So basically combines two types of pictures and it results in the final picture, which is also used during the training. Strong data augmentation allowed authors to increase AP for 2.4. Next contribution and change that they made is that they applied anchor-free detection. So basically in YOLO V3 to YOLO V5 in anchor-based detection, authors for each location predict 3 values, IOU score, classification score, and 4 bounding box coordinates, while in anchor-free detection of YOLO-X, they directly predict 4 values. So basically they have the center of the object, and then they predict 4 values which are closest to the boundaries of bounding boxes. And also authors predefine some scaled range around the center of the object, and locations of in this scaled range will be considered as positive samples and will pass to FPN to generate bounding box around the object. Anchor-free detection allowed to increase AP from 42 to 42.9, and anchor-free detection authors also needed to apply multiple positives, which allowed them to improve recall. So in anchor-based methods, as you can see, there is a significant number of true positive anchors. While switching to anchor-free detection, the total number of positive anchors is reduced dramatically, and that's why it leads to imbalance between positive and negative samples in training data. So what authors suggest is that they use a 3x3 area in the neighborhood of the positive location, meaning here they use a 3x3 neighborhood, so that samples in this 3x3 neighborhood will be also considered as positive samples, and it will increase the positive number of candidates to some extent and prevent some imbalance between positive and negative samples during the detection. Multi-positives are also made quite sufficient increase in AP, they increased from 42.9 to 45, and now after applying multi-positives, AP of 45 outperformed YOLO with the Utalytics performance, which was 44.3. And the last contribution that the authors made was Timota, which is advanced label assignment. So in anchor-based manner, authors assign labels of anchors as positive, negative, and don't care labels. The same was done with anchor-free detection. So authors apply Timota, which is the redesigned optimal transport assignment strategy. So in short, authors use the following formula, which calculates, the cost between ground truth and predicted bounding boxes, use both classification loss and regression loss with balancing coefficient. So for each ground truth object, basically they select top k predictions with the least cost between predicted and ground truth one. And finally, the corresponding grids of those k positive predictions will be assigned as positive labels, while the rest grids will be assigned as negative ones. So that for each of the ground truth objects, they were able to get k positive grids, which will be further used to predict optimal bounding box for the object. And as a conclusion, it can be said that authors, by using decoupled head, anchor-free detection, and advanced label assignment technique, which is Timota, authors were able to achieve better performance of the model. You can see here on the table YOLOX X version. YOLOX X version was able to outperform all YOLO series models at that time, reaching 51.2 AP. And the main reason why we are using this model in our project is that by having a decoupled head, it allows us to really manipulate and create more than one classification head and apply several data sets at the same time. That's why YOLOX allows us to do it and apply several data sets, and it has a great balance between speed and performance of the model. And yes, that's it. Thank you for your attention.